Welcome back to 1.1.2. This is part 3, and I'm going to work under the assumption that you know how to use the Desmos calculator or the Texas Instrument calculator or the graphing calculator that you have. So we're going to kind of go through this a little bit quicker this time. If you still need help with the calculator, please let me know or refer back to the previous videos. So we would type this in the calculator. Let's make our table of values, x and y. So when x is negative 5, y is 8. When x is negative 4, y is 2. Negative 3, 0. 0, negative 2. 3, 0. 4, 2. 5, 8. I just picked the values that gave me nice whole numbers. So we're at negative 5, 8. Negative 4, 2. Negative 3, 0. 0, negative 2. 3, 0, 4, 2, and 5, 8. And our graph does not continue going. It stops at those points. So that's what our graph looks like. So our domain and our range. Let's look at our x min and max first. X minimum, the lowest value for x is negative 5. The x maximum, the highest value that x reaches, is 5. So our domain is between those two. So negative 5 less than or equal to x is less than or equal to 5. That's an end inequality. We'll do the same for our range. The y minimum is negative 2. And our y maximum, the highest point that y reaches, is 8. So it's going to be an end inequality. Negative 2 is less than or equal to y is less than or equal to 8. And there we have our x-intercept. We can see across the x-axis at negative 3, 0 and positive 3, 0. And our y-intercept is at 0, negative 2. Problem number 2, once again, type this into the calculator, and we'll bring up our table of values, x and y, and we'll just put the ones that give us outputs of nice whole numbers. So we have negative 5, negative 1, negative 4, 5, negative 3, 7, 0, 9, 3, 7, 4, 5, 5, negative 1. Negative 5, negative 1, negative 4, 5 up here, negative 3, 7, 0, 9, 3, 7, 4, 5, 5, negative 1. So our graph is going to look like this. Remember, it does not continue past those points. So it's not really a parabola. So our domain, our x's are between negative 5 and positive 5. So negative 5 is less than or equal to x is less than or equal to 5. And for our range, our lowest value for y is negative 1, and that's less than or equal to y. And our highest value for y is 9. So our x min, negative 5, x max is 5. The y minimum is negative 1, and the y maximum is 9. That's just there to help you think about what our lowest and highest values are to help with our domain and range. And finally, problem number 8. Making our table, we can do that using the calculator. So when x is negative 12, y is negative 5. When x is negative 5, y is negative 3. X is 0, y is negative 1. X is 3, y is 1. X is 4, y is 3. So we're at negative 12, negative 5. Excuse me. I'm going to be off the screen here a little bit. Negative 5, negative 3. 0, negative 1. 3, 1. 4, 3. And our graph is going to look like that. So it's going to go down and to the left. So our domain, our values for x, they stop at 4 and they keep going in that negative direction. So x is less than or equal to positive 4. For our range, y is less than or equal to our highest value for y, which is 3. So our x minimum is negative infinity. Our x maximum is 4. Our y minimum is negative infinity. And our y maximum is positive 3. Now our x-intercept is not exactly at a number. Our x-intercept is about 1.75, 0. We'll talk about how to solve for those algebraically later on. And our y-intercept is at 0, negative 1. Okay, that just talking is about graphs. Really want you to learn about domain, range, minimum and maximum values, and really to practice using the calculators. I'll see you in section 1.1.3. Thank you.